So this is the Closure library talk. We're starting a little late because the main session went over. My name is Nathan Naze. I am an engineer at Google. I have a day job. It is Google Books, where I'm a UI engineer. Google Books is one of the users of Closure tools in general, and specifically Closure library, which is what the talk is about today. So I'm not sure that everybody is familiar with Closure library. We'll spend some time at the beginning just going over what it is and then how to use it. But view live notes and ask questions about this session on Google Wave. There's a bit.ly link. Can everybody read that? It's well, you can do this. If not, right there, if you want to type that in and you have a laptop, there's also a Google moderator on there. I've looked through the questions already, and we'll go through those, and then we'll also do Q&A at the end. So there's three major parts of this talk. The three parts are: what is Closure library, getting started with Closure library, and the reference manual. What is Closure library is basically just going to go over the library itself, talk about the history of the project. Getting started with Closure library will actually just do a brief overview of how it works and how it's set up, and then also a demo of how to get it working and using an actual application. And then the reference manual is just going on brief overview of the library. It's inconceivable that we actually go through every module and everything and go like that, but when you get home, you'll like to do that. We'll talk about some of the more out there points. So what is Closure library? This is the most important question. It's Google's standard library for JavaScript. Most applications at Google, Gmail, so the icons are at the bottom. Gmail, sites, docs, books, reader, blogger, calendar, that's not exhaustive. Maps actually uses it now, are written on Closure library. They use Closure library as a base. So that means these are applications that are written in JavaScript. One of the issues is that JavaScript is a dynamic language that isn't particularly well known for its readability or modularization. And so part of what Closure library is doing is attempting to solve that. With Closure compiler, which is also one of the Closure tools, it's a typed, object-oriented means of collaboratively developing complex web applications. So these teams that we're working on, these large JavaScript applications, they're not a single developer. They're people that, they're large teams. We work collaboratively. We use source control. People have to be able to read your code and understand what's happening. As I said, it's the JavaScript library behind Google's web apps. So problems we're trying to solve with Closure library, like I said, large-scale web development. We're working on large teams when you're working on complex applications. So as part of that, the tools themselves, JavaScript, HTML, CSS, the DOM, these are meant for web documents. Like the early days of the web are about creating a document, you build up from there, how do you script the thing? It's about modifying the DOM, it was not necessarily made for these large, complex applications. So how do we use those as tools, but in such a way that we can stay sane? So as far as collaborative development goes, what we're concerned about is maintenance and readability. These are applications that we're going to write and going to maintain, and we're going to have people coming out of the project that haven't used it in the past, that haven't read it in the past, that have to be able to go look at the code, see what's going on. We need a high degree of readability. We have, like most languages at Google, we have a style guide so that we require people to stick with. And you'll actually notice that if you look at the source of Closure library now, it's also very well documented in terms of comments on the code.js doc, which is actually something we'll get into a bit. But Perl is often derided as a language that is write-only. That you can't read somebody else's code when you go back. And one of the problems that JavaScript does not necessarily have a great reputation for readability or clear style, and it will vary across projects. One of the other issues about, I mentioned in the previous slide, Closure library is the standard library for Google. Unlike a lot of languages, the best case I think of is Python, which the quote is comes with the batteries included. It has a standard library that it's shipped with. JavaScript doesn't have that. It has things in the global scope, some very basic things. It's not a lot of functionality. What's exposed in the browser is an additional API into the DOM. But that's about it. So there's a lot of common infrastructure that isn't necessarily part of the language, and it isn't a standard library, and so you end up with this proliferation of different toolkits and the different frameworks, et cetera. Managing complexity. Additional to that, the development life cycle is of concern to us. We care about being able to maintain code in the future. Managing complexity is important to us. I don't want to know about all the internals of a class. You'll actually see this when we look at the code, but the way that Clojure library components and classes are written is very object-oriented. It's kind of, it's not procedural. And this is partially out of encapsulation. We want to hide the internals of the things that we're writing. We want to hide the internals so that I only think of these objects as interfaces. This is just classic object-oriented development. But that helps us work collaboratively because I write a class, I expose an interface on it. You write a class, you expose an interface. None of us have to care about what's below that. Modularization and conventions. So Clojure library, as I'll get into, is very broad. It's not like a classic JavaScript library, which is a monolithic thing that you include, and then all of a sudden there's an API exposed in the global namespace. Rather, there's a namespacing system, and I'll get into that. But you pull from it what you want. And that's very important to us in terms of speed, because we want the code over the wire to be as small as possible. We do that in two ways. One is to just pull what you want from Clojure library, and then secondly, in combination with Clojure compiler, which we'll get into, we want to make that minified. The Clojure compiler does more excellent stuff like dropping dead code, inlining of functions, but we'll get into that. And finally, testing and stability. One thing about Google development is that everything is continuously integrated, that we don't push versions of Clojure library. You have it as part of your project. You build it through the Clojure compiler. You send that out. But as part of that, there's a suite of tests that run. We run it as a continuous build inside of Google. We run it as a submit queue before you submit things into Clojure library so that all the tests are working at all the time. The other advantage of that is stability, that you can trust that things won't break over time. So Clojure library, let's give some of the history. It started in 2005. There's never been anybody staffed on Clojure library. Like I said, my day job is Google Books. My 20% is Clojure library. Actually, open sourcing it was an effort we wanted to do for a long time. Myself and an engineer in Sydney, Australia, Daniel Nadazi. This was our 20% project last year, and we open sourced it in November of last year. I think at last count, at least 400 engineers at Google have contributed at least one change list to Clojure library. It's also the focus of the talk. It's about 200, not that lines of code is a good measure of anything, but it's about 250 lines of JavaScript, not including the tests. So it's not small. Clojure compiler, which we'll get into more deeply, but conceptually it's a JavaScript to JavaScript compiler. We're not going from a source language to a target language. We're going from source input to a minified. For those of you that have done web development, you go from, you're familiar with minifiers that are taking a source, renaming variables, doing things, just trying to get it smaller, stripping comments, et cetera. It's doing all that, but it's doing a lot more. It's actually doing a full parse, developing a parse tree, doing transformations on that to both minify, but also take out unused code to check types, which is important, and we'll get into later. And make that, the output of it, which we refer to as a JavaScript binary, as small as possible, because that's what matters in terms of speed, getting that thing over the wire and getting it executed. The third component of Clojure tools is Clojure templates. This is used in some of our, very heavily in Gmail. It's basically a templating language that has both a Java server implementation and also the JavaScript implementation in for the client. And so you can send down a template, fill it, it renders out as HTML, and then you can use that on your client. Clojure library itself. Like I said, namespaces allow for a broad library. If we look at the source itself, it includes a lot, including the kitchen sink. There's everything from, the funny example we always use is there's a quad tree implementation, just in case you need that in your web development. Most people don't, some people have. But all to a widget set. So if you go look through the demos, you'll actually see a lot of the widgets that you're familiar with from a lot of the Google apps, because that's the ones they're using. And We care about this in two ways. We care that there's consistency across UI, across different applications, but we also like to share code because that's how we identify bugs. This is the third point there. More users means more found bugs. As we reuse these components, we identify things that change or things that aren't working correctly, and somebody goes in and fix it. It's Linus's law that, what is the exact quote? Given enough eyes, all bugs are shallow. Because we have so many clients using Closure Library, it helps us to find and identify these things early. The middle point, types and type checking. Like I said, the style of this is actually rather different than what you see in a lot of JavaScript, which tends to be very procedural. Take this div, style it this way, push it over here, animate it, whatever it happens to be. If you actually look at these things, if you actually look at the code, JavaScript has for people coming in from other languages, it has this prototype-based inheritance scheme, which is a little foreign. But I'll show an example in the code. But the thing about that is we're actually doing type enforcement by Closure Compiler. What's referred to as type hinting. So JS doc that exists on the top of, the JS doc that sits above methods is actually specifying these are the names of the parameters, these are the types we're expecting. This is, in the case of a constructor, it's actually saying this is of type whatever, it extends this, and the Closure Compiler actually takes that all in, understands it, develops the inheritance tree, and then does all forms of type checking, which is essential when you're doing these large applications where I want to know if I'm giving a function a type that is wrong. And that happens all the time in dynamic languages. Eventually, when you get to a large enough project, you're documenting in the doc string what the types are anyway, right? So why not make that formal? So part of the development of this is it's geared towards complex collaborative UI development. Why use Closure Library then? It's modular and broad, like I said, geared for complex applications and type safety and implements type safety on top of JavaScript, which isn't necessarily strong in that suit. Very stable and tested. It's what runs many Google web apps today, and it works well with Closure Compiler. Fair points. Why not use Closure Library? I won't stay on this slide too long. But it is a steeper learning curve. It's a more complex way of doing development, and it's actually very much geared towards a complex. It's very much geared for creating complex web applications. It's lower level when you look at it. It's not about exposing a small, understandable API. There's modules all over the place. They all have individual interfaces. It's great in that respect, but if what you want to do is pull up a div, style it, animate it across, there are a lot of toolkits that do that very well, and I would encourage you to use them because they do a great job of it. Use the right tool for the job. So some people, this is overkill. For some people, this takes care of a lot of the problems that are inherent in web development today. And obviously, we do this because we are working with these large, complex applications. But as part of that, while we're doing it, this is part of the impetus for why we wanted to open source it. We want to continue to develop this library, but we also want to do it in the open. And so that was the reason that we wanted to open source in the first place. So let me quickly go over the namespacing system, as you can tell, because it's on the slide here. Namespaces 101. So if you look at any Closure Library, if you look at any file in Closure Library, you'll see the first things at the top. Probably first you'll see a copyright statement and then a license statement. But then the first thing at the top you'll see is goog.provide, which is a message that's saying, hey, I'm providing this namespace at the top. So for those of you familiar with other languages, this is not a novel idea. But basically, these are the two ways that we express dependency. So when I say goog.provide foo.bar, it means I'm providing this namespace. This file provides this namespace. Goog.require says I require this namespace. So for this to run, I need this loaded, and this loaded, and this loaded, and this loaded. The result is a giant dependency tree. Hopefully a dependency tree and not a dependency cycle anywhere, because that makes it hard to figure out. This is unlike single file libraries. So one of the questions that we get on the discussion list is like, hey, this is cool. Why can't I just pull it in with the Ajax loader? So Google Ajax loader is a thing that'll pull a certain version of whatever JavaScript library. it doesn't make sense here. It's not applicable because inherently you're just pulling a subset of the Clojure library, just the parts you use, and then passing that on to, in production, you're passing that on to the Clojure compiler. So you're actually building a separate JS binary for your application when you're doing this. Pull a subtree of what you use. This is an example. This is actually pulled right out of goo.math, which is one of the lower level things for just mathematical functions. Like I said, there's no standard library in JavaScript, so we're defining all sorts of low-level structures like range, rect, size, coordinate, box, which are very useful, for example, in the style class to be able to express and understand something as a box or rectangle. But goog.math provides, or goog.math is a number of static functions. Goog.math.range, I think, is one of them. And then these are the requirements on it. So when I say in my file, goog.require goog.math, it's going to go to this file, see all these other require statements, fan out, grab those as well. And so the result is a dependency tree. And this is just, I omitted goog.math on these, so math array, math.size, math.rect, math.range. This is what you saw before, actually expressed as a dependency tree. So if I were to include just, for example, on this one, well, actually, I have a mouse pointer. If I'm just including math.rect, what that's going to require is, well, it's going to do the transitive dependency in the tree, math.box, math.coordinate. Those ones will get pulled. Hopefully that makes sense conceptually, because we're going to go into a larger. So when you actually think about this, and there's, I was just doing goog.math. There are, I don't know how many modules there are in Clojure library right now. The actual dependency tree, I think it's, the base one, it's like 500 or 600 individual files. So the actual dependency tree is very large, and if I were to graph it right now, it would not fit on a slide. So we're working with a reduced example. Let's say you have an application, which is green here. So foo application. I'm saying, so with this guy on the right, it says I'm going to depend on this guy. This guy is going to depend on both this guy and this guy, right? And so when we actually do the dependency analysis, it's only going to pull what's required. And so what turned gray there are the things from which there's no path down in the tree. And so when we actually build this, when we actually use it in production, we're just pulling those dots that are actually required, and we're doing that in dependency order. Dependency order being defined as anything that is required is loaded before it's needed. So you end up with a list, basically, of files. We'll get into a more practical example of that in a second. Type checking, just to introduce the concept. Stronger types JavaScript. For those of you that like reading JavaScript version stuff, there have been attempts at least introducing some concept of typing into future versions of JavaScript. But as far as it works at Google and within Clojure tools, we are doing it with JSDoc. So the JSDoc we're already adding. In the early days of JavaScript at Google, we were adding it anyway because we needed to know that this is this function, it's expecting an array. This is a function, it's expecting whatever it might be. But the Clojure compiler, which is actually, for those of you familiar with Rhino, which was a project to do a JavaScript implementation in Java, it's actually using that same code to build this parse tree, and it's also scanning those JSDoc comments to understand what the inputs to a method or function are supposed to be. So it's essential to collaboration. One is self-documenting code. I want to know how to use this, and the types tell me how to do that. Encapsulation, like I said previously, it's important for us to define these interfaces to things and then not worry about the implementation underneath. As far as when I'm interacting with a class, I mean, this is classic object-oriented design. But I want to hide the complexities of how things are actually implemented. I only want to interact with it as an object because these code bases are so big and nobody could conceivably know everything about everything. And so part of that is we're introducing concepts of private, public, protected that you see in other languages, but we're actually doing that in JavaScript, and it's enforced by the compiler. And as I said, how is this actually done? Like I said, JSDoc tags. So for those of you familiar with Java, there is JavaDoc. There are tools that take JavaDoc, turn it into nice HTML pages. We actually also have a tool that does this and have generated documentation for the Clojure library. So the type annotations are enforced by Clojure compiler. The phrase we use is type hinting. So these are not required to use Clojure compiler, and if you sit through a Clojure compiler talk, they'll get into this more. But if we have type information and we see that you're passing it something that is not valid as was defined in JSDoc, there will be a warning. And actually, for many projects using Clojure Library at Google, we actually have pre-submit set up so that we don't allow any warnings to pop up for our projects, because we don't want, it's indicative of a problem. Either you're doing the wrong thing or the annotations are wrong. So let's use a concrete example. This is taken from goog.math.sum, which is from the goog.math namespace I was talking about before. Brief note, Goog is kind of like the base name that we use for things. So goog.whatever, goog. And it also is representative of the directory structure. So here, this is a function out of the goog.math namespace. What it's saying is, I mean, obviously what sum does is return the sum of the arguments. The first parameter, which is variable arguments, is the numbers to add. The documentation, this is documented on the Clojure compiler site. The documentation is I'm taking a variable number of numbers. And so when you call this thing, it's actually going to check that that's the case. And then what I'm returning is a number that is the sum of the arguments. Make sense? So that when I'm using this in code, the compiler is going to say, when I call this, I want to check that everything is correct when it goes in. And then the result that I get back, we're expecting is a number. And when I use that to call other things, it's also going to be doing that checking, which is pretty cool. Similarly, let me talk about a user-defined, when I say user-defined, I mean not inherent in the JavaScript language. When I'm introducing a type that is not native, so for example, this is a UI widget called goog.ui.datepicker. The two that are in red there, constructor, this is saying that this is an instantiable object, and it extends goog.ui to component, which is one of the base classes in the UI subdirectory. Most things in UI are at least a subclass of goog.ui to component. But what's important about saying extends is that this tells the Clojure compiler that goog.ui.datepicker is a subclass of goog.ui component. And so when I say that I need goog.ui component as the parameter that's going into something else, that the Clojure compiler is like, oh, cool. Well, goog.ui.datepicker is a subclass, and so everything's cool, no warning. This is important. So let's talk a little bit more about Clojure compiler. I went over it briefly, but hopefully everybody gets the basic idea. What we care about is that as a basic thing, it lowers code size, or it shrinks code size. So this is the basic stuff that a minifier does, like renaming, removing dead codes. Or renaming is the basic thing, but what it also does is remove dead codes, inline functions, and more. And then code checking, checks types, function methods calls, syntax errors. It'll grab that before the browser does, which is important. And as we pointed out, it understands user-defined types. For those of you that are visual learners, there's a big box. So basically on the left, I used green and red, just similar to what we did in the tree before. Green being your application code, red being whatever Clojure compiler modules you're taking in. We say Clojure compiler, we would like to compile these as input. Goes into Clojure compiler, does the full parse, understands it as a full parse tree, does its whatever optimizations it wants to, and pops out the yellow one, which is the JS binary. And that guy's small. So getting started with Clojure library. So Clojure library exists as a project that's hosted on code.google.com, so it's just an SVN project. I should also mention that all the Clojure tools are here on Clojure tools, and then ours is library, which has links off to everything you need. We hosted it on SVN. So how to get it, click on source. Let's go to the terminal, close this, remove trunk for now. Oops. So what we are doing here, so SVN checkout, and that's just pulling. I just wanted to show what one does to check out Clojure library. It's pulling this all from the SVN repository. The way that this actually works in production, this gives you an idea of how many JavaScript files and things are actually in Clojure library, because it's going to grab them right now. But the way that this works internally is that our work is we're checking it into Perforce, which is the canonical for Clojure library. And then we're taking a snapshot of that and pushing that to SVN. So one of the things that we're working on right now, and actually if you're going to OSCON, Dan Bentley, who I'm not sure if he's here, is working on tools to do this in the general case. So we built it once for Clojure compiler. He's doing it in the general case to make tools to make the problem of going from Perforce to an external repository easier, and then also the reverse, taking patches to the SVN repository or whatever repository it happens to be externally, and migrating them into Perforce. So the points that are the points I should make here: SVN externals if you're using SVN. So when you do a sync, you can set up SVN externals to be able to pull Clojure library as well as a dependency. And so when you sync, it'll also pull updates to Clojure compiler or Clojure library. And then continuous integration. Some people are confused. I mentioned this earlier. Some people are confused that we're not doing versions. We just update the source. We find bugs, we fix them. And so when you're working as well, SVN externals is a great way of doing this, but just be tracking head. So one other point is server agnosticism. There are all sorts of front ends at Google. There are Java front ends. There are C++ front ends. That's what I work on. There are Python front ends. And so nothing about Clojure is tied to any of these setups. The negatives of that is that you're responsible for the glue. There's a small amount of work to get it serving Clojure library files, and then also to hook this into the compiler. It's not that hard. I'm going to do it on stage. How to get started. So there's a base file. It's called base.js. What that does is it sets up the loading system. It loads a file called deps.js, which is expressing where all the modules are and what all the modules are and what files they live in, so that when you require them, it can go fetch them. It does it, if you actually look at the file itself, goog.add dependency says the path, the namespaces it provides, and the ones it requires. User-defined namespaces use the same tools to make their own dependency files. So if you're introducing your own modules, there's documentation of this online. But you'll also generate deps files to tell Clojure library, I'm introducing foo.whatever, it lives in this file. So how this actually works in your stuff is include path to base.js and the possible additional deps files, as I just mentioned, but let's not worry about that right now, and then the path to my code. So let's do an example. So like I said, I just grabbed Clojure library right here. So that I just checked it into trunk right here. If we actually go to trunk, everything that you see in the library today. I'm just going to set up a Python server that serves out of my current directory, and then pop over to my browser, localhost. So trunk is right here. This is Clojure library as you'd see it today, and this is the namespacing that we have of everything. But what I did for this talk is put together a brief demo. So let me also bring that up in Emacs. Oops. Demo. Can't type. Demo.html. So this is just a simple static HTML file. It's pulling in a lot of CSS, as those of you that are familiar with HTML can tell. And then doing what I said before, pulling in base.js, pulling in the invites, and then just some simple HTML to bring up a little form to fill out. That form is, I wrote an application. I named it Nathan's Invites because that's my first name. I'm clever that way. So this is just as a static page. It's not doing anything special. I haven't done anything. I'm not using Clojure library right now. The date is May 19th, boring, 2010, time, who am I inviting, write a little invitation, click the go button. Just as an example, so at the bottom of this file, hopefully everybody can read this, I have a little call that I have commented out right now that's called invites.start. Let's uncomment that, save it, go back, load. And then it's actually, if I go to So this is actually, instead of doing what it did before, was just a static file. It's pulling in the date picker, allows me to pick a date, fills that thing for me, picks a time, 1 p.m., who am I inviting. It's using the autocomplete widget, which is already rendered, which is already pre-filled with some examples. So Harry S. Truman, buddy of mine, Thoreau, Hank Aaron. Those guys are coming to my birthday party and having a birthday party. Hope you can make it. And then this is actually using the rich text editor, which is actually the same one that you see in Gmail, which actually, when we said we were open sourcing Clojure Library, there was a push by that team to get that checked in so it would go out. And it's actually been a very popular part of Clojure Library, people just trying to get that. So normal, make it huge, click that, and then invite sent, which is just a static form. But if you had an actual application, you would go off and do whatever server-side work you had to do. So let's look at how that actually worked. Like I said, I had a script tag here called invites.js. It goes off and fetches that file. Let's just look at it. And at the top, I'm defining invites.start. You can see, as I was talking before, goog.provide, invites.start, all the requires. So these are all the things that I was using to do that demo. What's happening is that I'm loading this file. It's hitting all the other requires. It's fanning out and doing the dependency tree thing that I was talking about before. And then when I get to the bottom of this file, invites.start is started. And so it's just doing 4 things: set up the date picker, set up time select, set up autocomplete, set up editor. And if you're actually looking at this thing, you can read about what I'm actually doing to fill all these out. One great way to get an understanding of how to use these is to look at the demos directory. So if I go to, so like I said, I checked out trunk, right? The demos directory is right here, which is just doing common UI controls. It says pull out a button. Pull out button, there we go. How to use a button, whatever. But if you look at the source, oh, this is doing a frame. So if we open this guy in a new tab, and we look at the source, you can actually just go look and see what they're doing as well, which is a great way to just learn about the thing and how it's actually used in practice. Make sense? And then the one other thing that I will do is, let's go back to the demo. So I talked about Clojure compiler. So this is all, so actually, let me go back to the slide. This is all using just what we understand as the debug loader that we described before. There's the debug loader, which does essentially what I described: get to a point, go fetch the additional files that are necessary. The problem is you never actually want to do this in practice. It's a horrible idea to do this in practice because it was requiring an extra HTTP request for each time you're loading a module. So if it's not inconceivable that there are 200 to 300 files in a large, very complex application. Gmail probably is much larger than that. And so when in production, we want to compile it down both so that it's a single JavaScript binary, or in the case of some apps, it's actually doing multiple modules. It's pulling what's necessary to bootstrap and then additional things. But that's Clojure Library 201. Which is next semester. So there's essentially 2 modes: debug, which we just demonstrated, and then compiled, where we're actually taking those sources and we're feeding it to the compiler. The compiler is giving us output to create our JS binary, and we're using that in production. So when you're starting, you want to do debug. There's a couple of reasons to do debug. One, it's faster. JavaScript is interpreted language. If you're running on localhost, 200 requests over HTTP is not a big deal. But the more important thing is that you want to be able to use your own debugger. You want to be able to use whatever tools you're using. And when you're making an edit, you want to just be able to hit refresh and see that happen. You also want to be able to, when you're using your debugger, you can set break statements. You can use console.log statements, all sorts of things like that. Compiled mode, it's run through Clojure compiler. In most cases, this is one big file. It's small over the wire. And dependency tools prepare your compiler input, which I'm about to show you. The tools that we have to use this, the first one that we released with Clojure compiler is calc deps, which was what YouTube used because they didn't necessarily use the same build system that the rest of the that apps written on top of Clojure tools used. That's a legacy. There's a more recent implementation, which is a little cleaner, called Clojure Builder. There's an effort to build this support in the Clojure compiler. One of the things that we'd like about that is to have better support for non-Unix operating systems, because a lot of the development at Google is assuming that you're doing things on Unix at the command line. So let me show you an example of this. So the same demo that we had before, let's kill that server. So compiler, this is, if I go into compiler, this is just a checkout of compiler at head. It's just a jar, for those of you that know how those work. But what I want to be able to do is, what I'm doing here is if you look at this trunk Clojure builder, it's expressing two roots. Let me highlight as I talk. Expressing three roots, I'm sorry. It's expressing the root of the Clojure library. It says go search for all the Clojure library, find all the modules you see in there, look through the third-party Clojure, which is another, we have some amount of third-party code that we can pull into Clojure library that we want to also scan, and then the root, the files that I wrote. The input is demo.invites. That's the top of our tree. The output mode is compiled. I actually want to see compiled output. The flag is compiler jar. That's where the jar is actually sitting. And the compiler flags I want to add on that are advanced optimizations. So I want it to do the full suite of, not only do I want minification, but I want your code dropping. I want you to make this JS binary as small as possible. So if I run that, you see it work. What it's doing in Python is it going and scanning all the files that I just described, creating this giant dependency tree, picking out that top one, generating that subtree of the whole mess that I just created, and then sending that to Clojure compiler. And now it's thinking. So right there is the output. If you look at any Google application, you'll actually see the same thing where if you look at the source tag, it's this mess of code. This actually is written by humans, but it's gone through the minifier, it's gone through the compiler to get it as small as possible when we send it over the wire. So what we can do is just take the output of that and put it into compile.js. But like a cooking program, I've already done this. So if I go to my demo, I look at compile.js is just a compile.js is the output of the Clojure compiler, and we go to Emacs. We go to invites.html, and instead of loading this source thing like we did before, let's just cut that out and compiled.js. Go back to my demo. Oops, I killed the Python server. Oops. Start the server again, go back to my demo, reload it. And then now it's actually not doing this by requesting each module individually. It's requesting that one big file, that obfuscated JavaScript binary that I was talking about before. And everything works the same as it did. So this is what you'd actually want to do in production. And then I go invite my friends. So that's that. And then finally, the reference manual. It's inconceivable that we're going to go through the entirety of the library today, but I will do this briefly. Like I said, the code base, self-generated docs, we actually go through the JS docs, and oh, I'm having trouble getting to this server today, but we actually go through the JS docs and create a generated HTML view of all of these. And so this is actually in the SVN repository at SVN. It's in the docs directory at the root. One of the things is event-driven programming. Many things are subclasses of event target. So like nodes, you can actually put listeners onto these objects. They express events. They say, I'm a button, I've been clicked, I've done whatever. It's not necessarily just DOM nodes. We're providing basic utilities, which is JavaScript primitives, working with arrays, working with objects, things like that. DOM utilities for dealing with a DOM, style utilities on top of that. Network utilities be able to do XHR, XML HTTP requests, be able to do JSON-P, I/O. There's some amount. The actual class that's used, for example, in Gmail chat to have a long-lived connection to the server is in there. All sorts of things like that. It's a very broad library. Naming conventions. So the namespaces that I described before, goog.dom is going to be found in the DOM folder, style and style folder, xhrio. It just maps out, that's a convention. There's no reason it needs to be like that, but we do it for clarity. Like I say, basic utilities, array, string, math, object, URI, basic things for manipulating URLs, things like that. Data structures, oops, meant to click on that. This is actually doing, this is actually all the implementations of data structures that are in there. I should be able to view, for whatever reason it didn't come up before, but this is actually the generated docs that are taking that JS doc and generating the docs here. So if I were to click, for example, on one of them, URI is what I just described, it's going to have a nice pretty interface where it says these are the public methods to it. And it's hiding the private ones right now. Some people use that. Some people that are actually coding with it are using the source code to look through. DOM and style, goog.dom, goog.dom.classes. There are a lot more things in there for dealing with low-level DOM stuff. Style is the same way, goog.style, goog.window. And then for network, all the things I described, formats, goog.json, and then all sorts of just common things that you'd expect in a base library, like goog.date, delay, timer. It's pretty extensive. UI, I'll just go over this briefly, but the best thing to look at is the demos for everything that's in there. You just look at the directory itself, look at the demos directory, which is at /demos when you check it out. Everything is based, like I said, on component. There's subclasses of controller and container. There's too many to exhaustively list here. Big picture, it looks somewhat like this. We have data structures and DOM as a low-level library. UI sits on top of that, and over in its own yellow box. All the other utilities of network, random utilities, miscellaneous. Finally, it's important to mention that we keep a test suite. If I open that up, this is actually it's going to be faster. There we go. So some of these might go red, but what it's actually doing is pulling up off of SVN all of these tests, which actually sit in HTML files, and then are pulling in the necessary things, exercising them, and reporting back whether or not they succeeded or failed. And so we have infrastructure internally that's doing this continuously. So when people check in, we know what breaks, and we also do it as a submit queue so that we know that you don't break anything when you submit. I could go into one of these as examples, but basically, if you open up the HTML file, it's just a test bed for it to be able to run these things in the browser. And the important thing about that is the next slide. So there's a module called goog.testing that has all sorts of asserts and handling of asynchronicity, mocking tools, things like that you'd expect in a test suite. And then what's important is the test runner. So in Google, we have a test runner that's constantly running to be able to run these on different browsers. So it shouldn't, especially for things that don't impact the DOM, it's kind of odd that it would work on one and not the other. Although there are cases like the way they handle an extra comma in an array, which is annoying. But it's constantly fanning out and running them on a suite of browsers that are just existing in a farm, running all these tests continuously, and then letting us know if anything breaks. Make sense? The future, Google and open source. So one of our efforts was an open source project versus published source code. Our efforts was to extricate it from our build environment internally, to license it, and then publish that code. That was our priority. Closure Library was not started with the intention of being open source one day. And I actually, Books did a lot of JavaScript work before Closure Library exists, and it was ported to it later. And so I'm not even one of the original authors. But like I said, lots of internal build system, and it's been difficult for us to have non-Google code in the repository. But as part of this, we've been working with the Open Source Project Office to try to get around this. So I can announce that we can take patches today. This is something that a lot of people have, what's been annoying. What's been annoying for people outside and inside is that people will report bugs and include a patch, and we say for for legal reasons, we can't take that and check it into Perforce. We can now. So if you actually go and look at the source today, the copyright statements have been changed from copyright Google to copyright the Clojure library authors. We have an authors file, and we can take patches, bring them in. A Google engineer will apply them and put them internally. Part of Mo, the Make Open Easy project, is to automate that process so it's less onerous. We're looking forward to that. And that also, I've looked at the Wave. Some of the questions that were asked before this even started was, I'd like to see this functionality. I'd like to see that functionality. And it's been hard because I always want to say, write it yourself. And now I can. So, so this is always on. So the Google groups have always been Clojure library compiler templates discuss. A lot of traffic on them. I would encourage you to join them. And also, we want to try to, like I said, it was our effort to get this thing over the wall and to push it out there. We now want to foster the community. So we're starting up a blog, which different engineers that are working either on any of the tools, on compiler library or templates, will post notes and things up there. And also a Twitter account, which will articles that we see, interact with people in the community, and also as just a way to interact. And those are the announcements. So I should just bring up the Clojure Tools blog right here. It also has links off on the side to all of the things that you'd care to know about. So the home, the source, so compiler, for example, has a web service, which is a cool thing that you can actually do this instead of having the binary locally. You send it to an App Engine app that will compile it for you, which is fun because you just click compile and it does it. But on top of that, that should largely be it. So the Twitter account, we set it up. So let's do alert hello world. First post. There we go. That should be it. So you can follow that, or you can follow us. So actually, the funny thing is Google Reader. The two ironic points are this presentation was done in Google Docs in our presentations thing, which is written on Clojure library. So it's circular in that way. And also, if you follow us on Reader, that's also written on Clojure Tools. So let me go to the Wave, if anybody had questions during this. And also, I should go to the Q&A slide as well. So the Wave, the URL is right there. If anybody has questions, please come up to the microphone in the middle so we can all hear you. And I should also mention that Clojure compiler will be having office hours today in Space B from 2:30 to 5. I'll also be there. And feel free, if you see me walking outside, I'll be wearing a name tag with my name on it. Just grab me and ask me questions. So thank you. I guess we'll start with, I'm going to switch back and forth between what's on the Wave and what's on the mic, but please.
Okay, so I have a question about how does it integrate with jQuery and Google Web Toolkit, and is there anything we need to specifically do in order to make it work? Any problems do you recommend it?
So
like that.
I'm sorry. So one of the things is that as a design choice, we don't do anything to modify, and this is a problem in other toolkits. We want to do nothing that would impede your ability to pull in something else. So the major thing there is squash anything in the global scope, or modify anything expected not to be there on the prototype. So some JavaScript libraries will do this. They'll add functions to the array prototype or to the function prototype that actually, in the case, some of them actually squash things that are in JavaScript 1.6, which was a problem. So you can definitely use them both. We have talked about how do we try to integrate GWT, and there is functional overlap. We don't really have, we've talked about it. We don't have any particular plans. But there's no reason you couldn't bring jQuery in, use that. There is a query engine in Clojure compiler, but if you'd prefer to bring in jQuery, use that to pull in a DOM object, give that to something in Clojure. There'd be no reason you couldn't. Okay. Make sense?
So do we need to namespace the jQuery as
yeah.
well?
So the jQuery is just going to be something, as long as it doesn't interfere with anything in the global scope. So like I said, everything is, for us, everything is behind this Goog namespace in the top level, and there shouldn't let me know if you find anything that sits anywhere else, so it shouldn't interact. The only thing that would be a negative interaction is something else did something to modify a prototype, something like that. So
Thank you.
Yep. Let me also, so that actually, there's the wave that's on this too, because some people were asking questions remotely. One of them was actually related to this, which was interactions between, which I just answered, GWT and Closure. Yeah. So another one for the mic.
So this morning I saw this speed tracer thing in GWT.
Mm-hmm.
Does it make sense? Is Closure going to have the same thing as well? Or?
So some of the things you can do are, so if you look through the library, there are things to be able to do instrumentation. You can also use page speed to find places that you could speed up your code, what's taking too long to load. One of the other questions in there is, can you describe the best way to split a large code base up into multiple dynamically loaded modules in a way that resembles GWT's code splitting? So a lot of applications today, like Gmail, will actually, and Docs, you'll notice this, that it loads in stages, that is doing modules. That's one of the ways. It's a pretty advanced topic, but the way that's done is that there are command line arguments to the compiler where you can specify this should be compiled into module 1, this module 2. It's a pretty advanced topic. What we'll probably do is do a blog post specifically on this. So yeah, hopefully that answers your question. Okay. Is there anything else on here? Does anybody share any of the questions that are on here that's in the line? Can you provide a public roadmap? I should answer. So one of the things is that we try to have all of our discussions on Closure Library discuss about what we're planning on doing next. So things right now, things that we've been prioritizing are the announcements for today, the ability to take patches. But I think one of the things we'd also like to do is start organizing things and getting a list of wants, what people want to pull into the library or implement in the library, and either get people inside Google or outside Google working on those. For the mic?
Yeah, actually, on the comparing your library to others like jQuery.
Yep.
That's not actually my question, but just a comment. An appropriate question would be the scope of your library versus the scope. In other words, what are they?
Yeah.
Because people tend to pick libraries, and then if yours is very comprehensive, it looks good to me. I've done a lot of JavaScript doing coding. It looks like I'll take a look at this, and maybe that'll become what I use, assuming it has complete coverage of most of the things I want to do.
Right.
But then let me ask my question also, and you can answer both. Very basic question. Now I've done plenty of JavaScript. I've coded in Java in other worlds, but I haven't used GWT yet. My understanding is GWT enables you to program in Java and gets compiled to JavaScript. So, and you mentioned Gmail. I understand Gmail is a GWT application.
Gmail is primarily written on top of Closure tools.
That answers that question.
Yep.
Okay, so it's more direct JavaScript.
Yeah,
okay.
That's one of the things so there's 2 points there. One is that this is a broad and complex library, and it's intended for a very specific purpose. So the scope is different. It's also the intended purpose is different. So it's like what is better, Python or Java? The answer is both. There are things. Oh, go ahead.
I meant Gmail. The Gmail application.
Right.
Is written in GWT.
No.
Good. Okay.
Yeah. But what I'm saying is that there are differences between Closure Library and the things that it was specifically designed for. And there are cases in my day-to-day programming life that I'm going to choose Java for a variety of reasons. There's cases I'm going to pick Python for a variety of reasons. Same issue with Closure Library versus jQuery or any other JavaScript library out there. A lot of projects at Google use jQuery. A lot of projects at Google, a lot of projects, especially things that aren't things like Google Apps, Google Docs, things like that. But there are a lot of projects that actually are using other libraries at Google, depending on their purpose. Next question?
Yes, I'm doing a fairly complex medical imaging project. Mm-hmm. And we've decided to go with Google Closure as opposed to jQuery. And the experience so far, it's been very difficult because we find the documentation for the API, it's very lacking. Mm-hmm. And a lot of the times, even the demos don't work like they're supposed to do. So I'm just wondering if there is a better place than the public API where we could find, you know, how they work, and if not, are you planning on improving on the documentation?
So two things. One is, so like I said, this is all, so one of the things is we wanted to start doing this development in the public realm. So it's all 20%ers. So we don't have any full-time staff that is writing down documentation. The two things I would recommend you do are complain, go to Clojure library, discuss, say, I don't understand how to do this, because we don't know what's broken if nobody reports back. We don't have that feedback loop. So like I said, I'm one of a lot of engineers that work on this, and they all read that thing. What you don't realize is that if you go and post on there, a lot of the original authors of Clojure is always going to read it and respond to it. We've also opened up the wiki for public comment. We'd actually like people to, we have some internal documentation. We're trying to take that and put that on the wiki. But for pain points especially, we'd like to know more. One of the things is that inside the generated API docs, just taken from the JS doc that you see on in the code. Most of the time when people are working internally, they just have Emacs windows open and they're looking at this one on the left and looking on the right. The code should be the source of what you're looking at because it's going to be the one that's the best documented. That's what most engineers on that are using Clojure internally are doing. All right, thank you.
Good afternoon.
Hi.
Concerning open, my voice is too loud.
Yep.
Concerning open sourcing Clojure, what kind of patches are you guys looking for? Only bug fixes or new patches? Like we don't want to work too hard developing new patches and all of a sudden, oh, we don't accept this patch. How do we know what will be accepted?
Right, so obviously things that are minor bug fixes, there's not going to be a whole lot of contention. So one of the things I'd like to do on the external discussion list is identify things, you know, this is a module I'd like to put in, I have some interest in this. Bring it up on the thread because everybody's going to copy on that. Do that as an initial thing. Even inside of Google, like a change list of more than 300 lines is kind of odd. Because you know, this happens in the open source community where somebody like goes off, branches something, comes in with 10,000 lines of like, I've written you a new whatever.
You split them up in different.
Right, exactly. Because that way you're getting feedback along the way. One of the things about culture of coding inside of Google is you know, continuous integration. So people are submitting what they wrote, and continuous integration, and also code reviewing. So we bounce it, you know, before anything goes in at Google, before anything goes into Clojure library, we're doing a continual review of like, did you consider this case? This is, you know, this doesn't match style. You know, by convention we do this to try to maintain a good API. Are you
like our patches? Sorry, our contributors allowed to commit over time? Are you accepting external committers for the Clojure library?
So one of the issues is so we're just starting up with this now. So the way that I don't know at what point, it would not be my decision. It would be a decision of everybody about how we're going to handle upgrading people to just committer status. One of the issues is Mo is a nascent project, so the ability to make submissions to the external SVN and pull them into Perforce. We need to figure that process out better. Right now, it's probably just going to be sending a patch, working with an email. We're yet to do, you know, so far it's been announced for 15 minutes now, so we don't have the policy quite written, but it's something we hope to do. We'll bring it up on the list would probably be the best answer. And I think we have one more question.
Yeah. Both YUI3 and...
can you write in the mic?
Yeah. Both YUI3 and Clojure do dependency resolution. Doesn't that actually inspire more bandwidth rather than less if your application is multiple page? Because as you make your JS binary, you're including different dependencies and creating this large monolithic file per page. So you have no like reusability as far as just those particular script modules. They would be retransmitted every time, right?
No, it's a fair point. I mean, the other option is to always do per module, you know, this page only uses this and just pulls whatever, but you're still getting in the problem of having a whole bunch of HTTP requests going back and forth. Some people handle this by writing different binaries for each page. Some people handle this by trying to manage it as multiple components so that there's a base module and then what's additional for this page. The nice thing about that is that the base module is cacheable, and then the other one is just loaded incrementally.
Yeah,
But yeah, it's a hard problem in general. I agree.
Just the bandwidth and the actual JIT reinterpretation of the new file would be rather expensive, it feels like.
To do it just in time?
Well, so if you keep a file in cache, like your monolithic jQuery or whatever, if the browser is smart enough, it can keep that JIT compilation of it too. So you might
Entirely
want to
true.
consider that too.
Yep. So I mean, this is part of the logic of the Google Ajax API is that if everybody uses the same URL, they have that one consistently cached, and then if that's widely used on the internet, we don't pay that cost every time that people use it, and it's a completely fair point. I am 41 seconds over, so I'll have to let you go. Thank you very much.